Hello and welcome to another one of these ADD videos. Today we're going to look at some infinite limits, basic infinite limits to hopefully better your understanding. When we're looking at a limit such as this one, and it's just a polynomial, all you do is you really focus on your largest power. And because we have a 4x squared, we plug in infinity there, square it, you're still at infinity. 4 times that is still at infinity, so we write the limit does not exist. Second problem, when we see something like this, it's a rational expression, we plug in, again, we're going to get infinite over infinite. We don't care about the signs as much, and we write down the infinite over infinite. So at this point, we factor out the highest common power of x, and all I'm doing here to figure out what's left behind is I'm taking what I had originally and dividing by what I'm factoring out. So notice this x to the fourth is what I'm factoring out. And then these guys came from your original expression right here. So if you do that to the top and bottom, there's 4 x's common, or x to the fourth common to the top and bottom. Then what you end up with is this expression, which then simplifies to that expression. And all I'm doing there is canceling x to the fourth over the x to the fourth, x and x to the fourth give me 1 over x cubed, and then that nothing changed. Here we have x to the 6th over x to the fourth becomes x squared. So anything that's got an x in the denominator, if you remember, has a number over infinity, whether it's plus or minus infinity, will approach 0. So that makes all of these expressions go to 0 because they have x's in the denominator. And then we reevaluate what's left and plug that infinity or negative infinity in, square it, we get infinity, but then 1 minus infinity gives us negative infinity. Think of that as a positive 1 or 1 plus a negative infinity. That negative infinity is just so much larger. So any finite over infinite is 0. Those of you that took pre-cal, remember that when you were finding your asymptotes, if the exponent of the bottom was bigger than the top, it should be y equals 0, right? Well, that still applies here. So here when we're approaching infinity of this expression, plug in, you're going to get infinity over infinity. Don't put equal signs. Some professors don't like equal signs because it doesn't actually equal that. They approach infinity and infinity at different rates, so that's why they're indeterminate. You can't just cancel them out, okay? So if you factor out the x to the fourth, I skipped the step of writing hat over factor. You can do that and check your own work. Hopefully you paused this and tried these examples before doing them. So if you factor out the x to the fourth, then you get that expression here. And then after that, any x in the denominator goes to 0. You're then left with 1 over negative 1. Alright? So that then gives you the limit to this expression. And if you remember, if the exponents are the same, 4 and 4, look at the division of their coefficients. So those rules still can come in handy here in calculus. Hope I've cleared up the basics for you. Always just plug in. If you get an answer, you're done. If you get infinity over infinity, factor out the highest common power, cancel anything with x in the bottom, goes to 0 if the limit's approaching infinity. And then at that point, reevaluate what's left. Practice, practice, practice as always. Thank you and have a nice day.